Okay, students, let's proceed to again the next one, and next question is this. You are asked to find A, fog of -2, and B, gof of g plus g squared of 1 if gof of x is 3x minus 6 and g of x is 2x minus 3. So we are now going to talk about compositions of functions a little bit here. So look here, gof of the function is given, g of the function is given, so the only unknown here is f of x. F of x is not known. Since these two are linear functions, we have to consider f of x to be a linear one. But you students must be careful. If one of these two comes to be quadratic, you must consider a quadratic function, okay? So what we need to do is we have to consider our function f of x to be a linear one given by x plus b. Now let's start from the given information. You have been told that gof of x is 3x minus 6. So gof of x is the same as g of f of x, and which actually is g of ax plus b, because your f of x is your ax plus b as you assumed here. So g of ax plus b is going to come. Now what is g? G is assumed to be 2 times x minus 3. So whatever input is given for g, the output is 2 times the input minus 3. Now our input is ax plus b in g. So g is going to do, look, this one, 2 times the input ax plus b minus 3. As you see, 2 times the input ax plus b minus 3. Then what is this? Let's further simplify this. This is going to be 2ax plus 2b minus c. So we got g of f of x to be this one. But at the beginning we have been given that g of f of x or gof of x is 3x minus 6. So we need to equate this expression with 3x minus 6. Now two equations are said to be linear equations are equal if the coefficient of x and the constants match each other. So here the coefficient of x is 2a, as you see, whereas the coefficient of x is 3. So we have to make a means of matching these two. That is to say, 2a must be 3, and here 2b minus 3 must be minus 6. So from this, 2a has to be 3, as you see, and from this, a is going to be 3 over 2. Look, we are running to determine what f is going to be. So a is 3 over 2. What about b? Look, b, in order to find b, look, come here, 2b minus 3 is a constant one. But you have been told here that minus 6 is again a constant one. So you need to equate these two. 2b minus 3 equals minus 6, as it has been stated here. So from this, b is minus 3 over 2. So once we determine these two values, a and b, what is known here, f is known, because f was written as ax plus b. Now we have determined a and b, so matter of plugging these two values here in a and b, so we can have now f of x to be 3 over 2x minus 3 over 2, or we can say 3 over 2 into x minus 1. Now f is determined. If f is determined, we can talk about, or we can find what fog of minus 2 or fog of x. And in order to determine that, look here, fog of x is the same as f of g of x, as you know. And here we are having f, and in place of g of x, let you take g of x. Where is that? Here it is, 2x minus 3. You simply take this one and put it here. Now look, this is f of 2x minus 3. F has been defined to be 3 over 2x minus 3 over 2. So you simply substitute this 2x minus 3 in place of x here, okay? So doing that, make this one, okay? 3 over 2, look, 2x minus 3 is directly substituted. Then minus 3 over 2 comes here. Let's simplify. 2 cancels 2, then 3x can come. Here minus 9 over 2 can follow. Minus 9 minus 3 minus 12 over 2, which actually is minus 6 can come. So finally you will obtain fog of x to be 3x minus 6. And even though your interest is not to determine fog of x, look, the question says fog of minus 2. This is a general expression. So fog of any sort of, you see, a fog at any sort of number can be determined by using this general expression. But now you are particularly asked to find fog at minus 2, so you can directly put minus 2 in place of x here. So look, fog of minus 2 is going to be 3 times minus 2 minus 6. Put minus 2 here in x, you see, this brings minus 12. Okay, so a is answered. Now to come to B, what we need to do is look, this expression is a certain function. It is made by combination as well as compositions of functions, as you see. Compositions of functions and combinations of functions. When we say g squared, we mean g times g. So we are now going to consider gof of g of 1 plus g of 1 times g of 1, right? So everything is now determined. G is determined, f is determined. So it's a matter of now plugging or substituting this value, number 1, in place of x of the corresponding functions, okay? So this can be done as follows. You see, gof of g plus g square of 1 is going to be, you see, this one. So we can write this like this, g of f of, look, g of f of what, students? G of 1, you see, g of 1, as you see, plus g squared 1, g squared 1. So as we studied before, or as we obtained before, this is g of f of, what is g of 1, student? G of 1 is basically 2 times 1 minus 3, because g of x was given by 2x minus 3. So putting 1 in x, you can have 2 times 1 minus 3, plus this says g squared 1, so it's going to be g of 1 times g of 1. So from this, one can obtain that this is g of f of, what is this? This is minus 1, because 2 times 1 is 2, 2 minus 3 is minus 1, plus, what is g of 1? G of 1 is nothing, but it is having 1 in 2x minus 3, so 2 times 1 minus 3, the same is repeated here, 2 times 1 minus 3. Now look, this is going to be this one, look. It has been said that, or calculated that, f of x is 3 over 2 x minus 1. If you remember, we have done this in A. You can go back and observe. So this is g of, look, this is g of what, students? 3 over 2 of x minus 1. But in x, students, we are having minus 1. So we directly substitute minus 1 there. Minus 1, plus come here. 2 times 1 is 2, and 2 minus 3 makes minus 1. So you will have minus 1 here as it is. Here also, you're having 2 times 1, 2, 2 minus 3, minus 1. So from this step, we can have this one. Now what follows from this is, you see this. Look, minus 1 makes minus 2. Here it is. And here, minus 1 makes minus 2. So minus 2 times 3 minus 6 divided by 2 makes minus 3. So now we are having g of minus 3. What about there? We are having a product of 2 minus 1s here. You see, 1 is obtained from g of 1 and the other is obtained again from g of 1, okay? So we are having minus 1 times minus 1. So obviously, the product of the two turns to be positive 1. So you see, this complicated expression now is coming to simple one, being g of minus 3 plus 1. And we knew what g of x is, as it has been already defined. G of x, look here, g of x is 2 times x minus 3. So we are going to substitute minus 3 in place of x, okay? And then we should operate that one with 1, okay? So this is going to be like this. Look, g of x was asserted to be 2 times x minus 3. You see, 2 times x minus 3. Then you have plus 1 outside. So directly in x, you need to take minus 3, okay? You need to take minus 3. Now what's going to come? 2 times minus 3 plus 1 can come. And here, 2 times minus 3 is minus 6. Right? Minus 6 minus 3 makes minus 9. Or a negative 9, in fact. Negative 9 plus 1 is what, students? Negative 8. Negative 8 can come, right? So this makes, finally, what, students? Negative 8. So from this, you can understand that, you see, functions can be formed by 2 different approaches. One is combinations using the 4 mathematical operators: addition, subtraction, multiplication, and division. And the other is by using compositions of what? You see, different functions. And so in order to generate new function from existing 2 functions, we do have 2 methods, right? So these methods are combinations and compositions. In the case of combinations, we are going to use those 4 different mathematical operators: addition, subtraction, multiplication, and division. But in the case of composition, we don't need to use these 4 mathematical operators. What we need to focus here is the range of one function has to be, you see, a subset of the domain of what? The next one. because in the case of compositions of function, what has been taken by one function is received by the next one. It is such kind of process. Okay, this is what you need to know.